Hello, everyone. Thank you for joining us today in this new Rhino user webinar. I am Guillermo Varela from Magnet Europe, and I'm here today with Ashkan Rezaee from Henning Larsen. He will show how to codify the data model using system and workflow architecture inside Grasshopper, instrumenting prototypes for real-time feedback, and converging toward a plugin. Remember that in the last 15 minutes of this webinar, we will have some time for Q&A, so if you have any questions, you can ask them in the chat, and we will check them at the end. Also, I would like to mention that the webinar is being recorded and will be available on our YouTube channel, where you can find more webinars and tutorials. I will try to upload this one tomorrow morning, and I will send you an email when it's available. Thanks again, Askan, for accepting for accepting the invitation, and you can start with the presentation if you're ready.
Thanks, Guillermo, for invitation and also for introduction. Super happy to be here. I just go ahead right away. In the beginning, well, I'm going to share it with you. Okay. You see my screen now?
Yes, perfect.
Okay, great. Hello, everyone. My name is Ashkan, and today I'm going to show you different things. This is initially the idea was to present the workflow that we're doing at Henning Larsen, but I thought because I saw so many people that I didn't know and probably didn't know me will join our session, and I know the background that you might have. So I'm going to do a quick question mark introduction of myself. Like the question mark is because I'm going to talk about a little bit of myself, like how I got into doing what I'm going to show you that I'm doing right now. But I'm an architect in background, so I'm coming from, if anybody from architecture have education in architecture is in within us, they know that we've been part of all this literature, learning from different architects and how we work with form and grid, and how we kind of educated ourselves within all of this paradigms with geometries and so on. And this was one of my first projects that I kind of got into using the digital tools was with Grasshopper. Using Grasshopper to work with geometries was a facade kind of tessellation optimization task, which I worked with, which I really enjoy, was somehow bridging between something that I was going to learn more about and something that I was really passionate about even before I started doing architecture. And it was always about how to narrate this story, how we can connect all of these dots together. And it kind of amazed me how easy it could be using digital tools to bring that concept and essence to your design and kind of figure out how we can evaluate and tell a story. And those story could become sort of um, part of the things, part of algorithms, or part of motions that we could create similar to woodworking. I would say there's like a digital craftsmanship where you could use those knowledge and use those ideas to bring into this machine, and this machine can create things or visualize things or imagine things for you. And I use a lot of this small bits, as you saw before, it was like form finding. And for my thesis, which you can, for my master's thesis, that I used a lot of point clouds, different algorithms with constraint, with VR, with actually noise in terms of mathematics. And during this time, I was also working on different way to visualize and make things beautiful, of course, because this is basically the basis of creating something as architecture. Aesthetics is quite important, but what is behind all of this, there is mathematics and there is algorithm that can drive these forces or drive these geometries. So I wanted to talk about all of those background because when I started to work with more, let's say, environmental studies at my current position, those ideas, those algorithms, those logics could kind of translate to become powerful tools to create these changes or evaluate things, which was mostly or merely in the past about creating this beautiful form or creating this mathematical or visual way of communicating, turning into something that you can build or something that you can evaluate in terms of different aspects of design, if it's daylight, if it's areas, even if it's CFD modeling, which we're going to talk about a little bit more. And it was a very interesting journey, as in a way that you could use the same idea or same mindset to bring it to something that is quite different than what you thought that it would be only applicable to. At Henning Larsen, we are believing expertise, and we are working with like together. We're working with each other, and we have different expertise in terms of specializations and also area of interest. There's this scheme that there is in Denmark that people can do industry PhD, which is half doing it in academia and half do it in practice. And we always have in-house PhD students working on specific topics, and they are quite diverse. And these give us this opportunity to work within different areas using these digital tools to bring some valuable understanding of design in different scale of the project, from a small buildings to commercial buildings to urban planning to landscape to high rises and so on. And it's about how we use those powers or knowledge to bring it to different projects, competition, how we can visualize them in a way that it's communicative, and we know that if there are things that we can make it better, we have tools for it to show it to like depends on the outlet. So this is, for example, one of the projects that we wanted to combine all of this endeavors from our end in our R&D department, where we wanted to show that the places that we create for these commercial buildings, they can provide very good and comfortable outdoor environment, whereas they can also provide the facade and all the juxtaposition. They can provide enough daylight for the different floors on the building. But the way that we communicated, this went through different steps of simulation and analysis, and but at the end of the day, we wanted to create this holistic approach and strategy towards sustainability, or better said, something that we know for sure that we can make it better. And this is part of our ecosystem, everything that we use. It is not as clean as it is in front of you that you see, but just to show you the type of things that we work with different tool stacks, or we work where we don't really focusing on using very specific programming languages or programs. We have favorites. Rhino is one of them, which we were going to talk about it a lot. But we tend to, during the past few years at least, to also investigate how we can examine our opportunities in different areas. For example, we work with different universities as a research project, for example, this project, where we work with the College University to bring the high computation on GPU with OpenLB on our local machines, for example. We work with, for this project, for example, there was this competition that we won in Singapore, and for awareness, we created this map, which you can go and see, that shows how different it would be in the future to navigate the city, walking and biking, given the fact that the climate change is happening. And the tools that we created is quite diverse. So this is also another project that we work with. Started as Excel file, presented in a Speckle viewer in a platform which is accessible. You can also find this on our website, and it turned to be a plugin on QGIS, which is also Python based. And a year ago, we started also this research project, which is a repository for biogenic junction details that we're going to launch very, very soon, which was built on top of different tool stacks from React to Postgres at the backend and so on. And we wanted to experiment all of this into Rhino, and I wanted to talk about this world, and I'm going to talk about the things that we do in Rhino or we've done in Rhino. We had this library of tools, like from Grasshopper scripts to different plugins, which what you see is one of the newest one that we work with. And here we try to implement, it was early, I think it was summer of 2024 last year, if I'm not mistaken. They wanted to, before MCP, we wanted to bring that power that AI has into our workflow. So this was one of our kind of excursion to find out how we can use this. And then, yeah, again, we try to create RAG software on top of our knowledge base. We try to participate in the hackathons. This is also recent. You can also check it out to see how we can organize AEC data and like file system, basically based on ingestion and, again, RAG or CAG, which was very successful. And working also with image models coming with AI as well. This project, I think back in a year or a year and a half ago, how we can bring those ideas or those spirits in Copenhagen. Now this project is based in Copenhagen. Those ideas and living spaces into AI, which is a little bit senseless in terms of emotion and empathy, how we can bring those values into our generations. And all of these tools, all of this like beautiful wall behind this, we have, I put this here not to show that how it is, because sometimes it feels like if something crashes, it doesn't make you really happy. But this all happened because we get to work with people in here, and they are very good feedbacker. They give us very good feedback all the time. And then we get to work, because sometimes the workflows, maybe the digital tools in general, you can interpolate them and you know what they do. But the use of the tool itself, it's kind of a mystery until somebody get to use it. And the best tools that we made, they were the most miserable first usage that we could see in the office. And then during the iterations and during the conversation and the communication with the team, we get to work on different tools in a more efficient way. And from the time that there was this time that everything, it was like everyone wanted to bring everything to Rhino, and it made sense, and it still does to some level. Because the environment that you are comfortable with modeling and giving objects and your model attributes that you can visualize and you can quantify and you can run simulations on was very comfortable. But lately, there was this point that we realized that we are working, for example, with OpenLB team, and they don't have any idea about Rhino. They are working terminals mostly. And maybe Excel, but we wanted to work with them, and we wanted to work with Rhino, but we need to kind of come to an agreement or being on the same page with them. So it was something in the middle that we choose to be at, which is not fully centralized Rhino plugins or Rhino tool chains, but partially distributed system where we could bring all of these tools into a place that Rhino can get access to it. So it is like everything starts and ends in Rhino, but there could be journey that we could get them into different cores. And I'm going to talk about the cores later more. And um, then we can get it back for the user to see how things perform, or for whatever reason they use these cores, if it's exporting, if it's sharing, if it's calculating, for any reason they know how to get access to those values. So there are some things that we have it. We try to kind of localize it on our machines, because nowadays all the machines come with very good GPU, and we know the GPU software ecosystem is quite rich, and it's getting richer every day, because now there are much force and investment in AI and use of GPU as a hardware, as a main hardware for many computations. But also we wanted to create more accessible platforms and outlets to get access or to connect to other tools. If it's our tool, or if it's other people's tool, if it's an online tool, open source tool, we wanted to be able to use them, or at least we have a way to connect with them, or HPC workflows, or we wanted to have different structure if we want to use open source, let's say query language that works on the graph. We wanted to our structure should kind of comply, or should work with those kind of um, um, data model. So we need to have this in mind as well. So we cannot really work in this silo. And this is basically what I'm going to get into bit by bit, is our CFD workflow. We wanted to, like, this is from like one of our projects from before. We wanted to create this pipeline. We have this pipeline, but we are going to revamp it a little bit, and I'll show you how we are working on it. But at the end of the day, what we want to have, like, all of this should contribute to the fact that we could have this comparison, we could have this iteration, and we can make best decision based on those results that we get from the systems. And that is always the ultimate goal for everything that we do. As much as I would talk about how great very specific tools or technology is, which I really am excited about, but at the end of the day, we have to make sure that this will communicate well, communicate correctly, and it creates value. So just keep that in mind as well during this process, because we're going to talk more about a little bit more technical stuff. So the formulation of what is like what I'm going to present next based off is on 4 different pillars. It could be less or more in the future. But there is one thing about object attributes, which in our case, or in today's case, is about the values that you would give to your objects in your CFD modeling. And by CFD, I mean OpenFOAM wind simulations. Modular design, because then we have different modules that create different values for you. So we have a module that assign values to different objects for you. There are some modules that control the process for you. If they are in the same order, once the process is finished, it should go to the next one. If there are different services, and I'll show you how the services is modularized as well. There's this connection, and this is also basically the connection between the data model and specifically to your microservices. And I want to use microservices as a term loose in here, There are some microservices that are really microservices. They live in a container and you can use them, but there are some small functions slash microservices that you can just take your data. It's like nodes in Grasshopper. You can take your data from one node to another, and then that can provide values. But the idea is that small node or that small service can be maintained by a team. Whereas if you have everything connected to each other in one piece, everything should be maintained by one big team. And at the end, there's a computation, and it depends on the type of a computation that you need. For us now, this runs locally because it's in the development phase, but it depends on the type and how heavy your computation is. It can run as like if it's an area calculation, we'll see it. It will be like a matter of milliseconds. If it's something that runs real time, but not milliseconds. If it's something that is like 2 minutes, if it's something like heavy as like millions of cells in a safety modeling, potentially this is what also what we aim to do, to use cloud infrastructures for this, to be able to with the behavior of the elasticity that it has, we can just expand our services as much as we have work in the pipeline of simulations. The first part, that's semantic or this object attributes. I'm going to mostly talk about the CFD context for now. So you can assign different values to different parts of the buildings. If there is a building that you want to tessellate more because you want to see more more of a detail of that building, or there are some trees that you wanted to simulate in your safety modeling that they have some effects in the way that the your simulation or the wind flows and so on. And on the right you see the key values in Rhino, which is also basis of what we're going to talk about. And this modular design is where you have basically text-based, this is JSON, where you have all this config files within Grasshopper, within Rhino, or outside of Rhino, where you can track back. This could be also a database where you could have IDs or key IDs that they can kind of connect and link together. But the idea of having data models that you can kind of connect to each other within IDs or what have you, I think this is something that we wanted to implement in the whole process, because the changes that we are going to make within the model, if it's one object or two objects or the whole model, I think it makes difference, and we wanted to keep track of those. And this connection that I talked about, there are connection for services and connection based on different data model. You could have like a big chunky data model, but each part of the data model can communicate with different part of your microservices or different part of your design, your system. And some of them are auto compute. It means that we have something that later I will show you. It computes the areas automatically. You could have presets like what I'm going to show you again, that you could have presets for trees, for example, presets for tessellation on different buildings. And then you could have custom values that you wanted to assign to your, I don't know, if you're working on something very specific, which we also wanted to implement it little by little. If it's within like urban design, social design, LCA calculation, and so on. And then you could see that the computation, where you could have local or cloud or serverless, or you have like a big server in your house, and they can work in a way that if they're modularized in a way that you could kind of distinguish between different services, you can create a native components that they can be deployed on something like GCP or any in cloud infrastructure, or if it's in a like open source software which you can host it yourself. Now I'm going to show you this workflow that I was talking about, and that was just some background context that maybe it's better for you to know. So in order to achieve that, I'm going to talk about first dynamic component. So what you see in here is I have a model, which is a very, very clean model. It's not for it's not project based, but I made this so I can include many different diverse types of objects I have. Let me just put this in here. So I really need to show you. Just gonna remove all the key values in here. Remove these. So in the assigner, so there is this component that serves as this object identifier. So where you could have different values and don't mind the other values that are work in progress, but these three values, once you change them, could have different inputs. And it's smart in a way that if it's solid, it asks you for very specific inputs because this runs on OpenFOAM. And I have different setup in here. This is where you can set up basically those attributes to your objects. Just want to show you what you get as an output from this. Different levels, like refinement levels, different levels of tessellation, if there's preset, and if there's a roughness, which you could also change the roughness based on the roughness of your object, levels, refinement, and so on. And there is this other component which assign those values to what you have in there. Again, you can choose which one, like these ones are the ones that I use because later, this is the way I label the objects later in my backend. I want to show, or I want to filter them out in a way. You'll know what I did this, but you can easily assign all those values to your objects, and you can just like assign it to all of them as well. And it's very useful for our colleagues, for example, because this in our current workflow, people need to know about the roughness as values or how much of the values that they need to put for different vegetations and so on. But there is this kind of a heuristic approach or more informed decision based on what you can assign those numbers to actual trees or porous objects like fence and so on. So it is easy for you to just choose between what you want to have, and then you can turn it to something that behave in a way that you expect a street tree, for example, or a street tree during winter. We have a winter leaf off to behave in your model, where you can assign. Now I want to change my model in here, and it changes. And then all of this, then you have a model with like all of them has some kind of a value, and they know how to behave once you have it in the backend. But this is one of the modules that you create, and this can be maintained or created or be added with different values that you might have for this model based on the tool that you use. If it's you want to be in control of different parts of your software of choosing. And the component here, so this is made for CFD modeling, but there are two different modules, which I told you to ignore for now, but one of them is CFD setting, which you can create. This is more of a general setting for your CFD modeling. You can choose the speed of your setup, the angles that you want to run it for, different models that you want to run for. We usually use RANs for quick studies. And then again, for using some of the values that are not really known how to use them, you can use more qualitative values, and it chooses it for you. And then this component, this is also reads all the key values from your scene where you have this specific. If you notice, I try to mark all of my models based on a key values like the prefix that later I can read with my harvest component. And then at the end, you have this huge output, which this is actually, maybe it's not all of it, but you see that all of them are connected together. I wanted to export, I did this for a test before. Maybe I will just make McNeil number 2. And then you export this and then you get these two files. In the constant, you get all the files that you have in your model. If it's just solid, but if it's porous, it will be in the folder porous. And if you have any trees, it will be in a tree. And they are all marked with, just again, if I have this open. So the general information or general setup config that you had, you have it in here. And then the mapping is whatever you need for your bounding box, which is calculated automatically, for your buildings with their name attached to them, and so on. All the information, and they're all linked to your model. And in the back end, just want to show you this. So what I have in here, it is, maybe I show you, there is 3 parts for just very simplified version of it. There's a worker, there is an API, and there's a Redis database, which I use for keeping ephemeral data every session that I have this on my computer. So API, what it does, I have a front end that I can just upload. And if you didn't see this, the script also in Grasshopper provides this zip file, which you can later use to drag and drop to your front end. It connects my worker and my Redis storage to my front end, where you could upload and then get all the logs and feedbacks on your front end. And what it does, basically, once I upload it, it goes to what I use in here. It's called Jinja. I have templates for all the dictionaries I need for my simulations, and they're all based on templates that Jinja provides. And I have a script that it reads all of those JSON files that you saw and generates these dictionaries in a very specific folder format. And I want to show you what how it should look like. Like, this is not a product of this simulation, but I just want to show you now how it creates it. So you should have, and this is a done project, this in meshing. It will create all this dictionary that you would need for your systems, for the mesh quality, for decompose, or if you want to parallel it or block mesh and so on. And then we'll start your simulation. and I use Celery in this case, which helps me to have each task based on the outcome of the previous task. So if the meshing is done, it goes to the simulation. Just want to check and this is how with dynamic component we can apply those values with key value signage. We get to assign those values as a key value pairs in Rhino. Okay, I wanted to show you this and for making this, and also this is part of like we usually use Grasshopper as a sketching tool. So we sketch things in Grasshopper, and if we need to bring it to more of a surface as a plugin or as a tool, we take that idea and logic and turn it into a plugin or web app or something like that. But for me to understand how this could be visualized and how we can benefit from this, and if this can communicate it with people who are not familiar with this with this specific development, the first thing is how we can know that like how many buildings we have or how many blocks we have in here. It's just blocks, and how many terrain we have. So this is also, it could be a report panel that you could have. This is based on the foreground draw in Rhino, and it creates it for you. The other thing is how I'm gonna be sure that these are the ones that I'm picking up. And these are the tools I've been trying to make the process of turning safety model or modeling into something that is very visual. And you can hover and you can see the buildings, their names, and also the buildings that they're on the same stack. They all have the same name, but within different enumeration. And you get to also see if you have different levels or levels of how do you say it? You can filter them out, and you can color map your object based on the values or attributes that you gave to your objects in the key value pairs. And this is based on the values. I know that the ones that they have the same color, they're going to be tessellated in the same way. And you can do it with types. You can do it with refinement. I got some error, probably runtime error. You can also have it with names, which is useless in this term, in this case, but just for a demonstration purpose. And then the visualization and harvesting data and binding data, exporting data and translating those JSON file into dictionaries, which is done by Jinja and a Python script. And with Celery, we instruct the task, how the task should proceed. This is something that I also wanted to share with other people because it was something that I really enjoyed. And I haven't really posted all this blog post, but I will do it soon. So if you want to, you can find it. I plan to do it in December. I want to continue this because some of these ideas and logics and pattern, let's say the software pattern, we found it very useful that we could bring this already to a plugin format in Rhino, which is not only about safety modeling, but it is about semantic in general. Semantics that not only you can define your objects based on what they're going to be in your safety modeling, but the areas, the relationship that they have, something similar to space syntax or something similar to a data model that you might have with the speckled data model, something that you can plug into any other system. So, and this is running on debug. So if there is an error, because it's in work in progress, but basically what you see is those, we talked about auto compute. Okay, I got disconnected for a bit. Auto compute. So the area is auto computed in this case. So you get to see your some of the numbers that you want to see in real time, which is not groundbreaking, but the fact that you can create, I think this is a different task actually from the things that you can do and compute and run and calculate to some level in Grasshopper and in any format or scripting to something that is way easy and comfortable to be used and intuitive as a UI. And this is something also we're exploring. It's not about what type of tool chain or what type of tech stack you use, but it's how those can communicate. Because if people are using this, they don't really care about what's behind this. I do. I love the fact that it works on JavaScript, on Next.js, and the fact that I can just get all of my information breached within the run a plugin and my Next.js app, and then this gives me this possibility to work with some of the tools that I'm more comfortable with, for example. But just for you to understand, these are the things that you can use. The idea of getting the most out of JavaScript ecosystem and the way you can visualize things into Rhino, I think it's quite interesting. And this came with updates in Rhino 8. I'm not 100% sure, but I think the viewer 2, which is way better and more integrated with all the other tools. Some of them are not really implemented. I wanted to talk about auto compute, which was that one, and then I wanted to talk about presets as well. So the presets, what it is that I'm interested in, because we wanted to have this only for safety modeling in our development environment. But what is initially, or that would be the ultimate goal, is how we can generalize this into something that we can use for different purposes, because semantics is not only about one thing. In our case, in our projects or the way that we work, as we talked about, there are many experts in the house. We have many research projects, PhD students, how we can bring those ideas, how we can help them to collect that knowledge into this piece of software so everybody else can use it in our office. Which is, to some level it exists, but to some level it can be way better. It can be more integrated. People could have their own opinion and they can learn how to use it. And by learning how to use it, it is not learning something like Revit how to use it, which might take some time, but is how to use ChatGPT, which is another thing that I don't want to broach into it in this session. But yeah, we have these presets which we're working on right now, and then this becomes more holistic approach to tool making and bring those ecosystem, because formerly we had this libraries of tools, but they weren't really talking to each other. But with this idea, we get to put the tools together in a way that they can talk to each other. If they're old, if they are newly developed, or they are developed 5 years ago, they can still have some kind of a connection, and the maintenance and so on, they'll all be way easier. I want to end with this, but I would love to answer any questions or any criticism or any comments if anybody have anything to say.
Yes, thank you, Ashkan. It has been very interesting. There are a few questions in the chat. Patrick Bethoff asked first, how big is Henning Larsen R&D department and how is it financed?
Okay. I don't see it, but I will answer it because I heard what you said.
Okay.
There are, I think, with PhD students, there are maybe 15 of us, more or less, give or take. And we work on projects, research projects, and research projects are funded by different parties, and projects is based on different parties as well, different clients. And some of the projects we worked on, for example, hackathon project, it was just us trying to do something new. So all these endeavors they initiated based on different reasons. But yeah, that's it. That's the answer for
Okay, thank you. And he also asked if you use Speckle.
Actually, people who know me, they know that I'm very fond of a speckle. We use a speckle. I use it like we have a partnership with them. We use a speckle quite often, I would say. And what you see, for example, in our Urban Decarb app is something based on Speckle data model and Speckle viewer. And recently we got it updated to API 2, which is way nicer. Like it's always been nice, but this got me very excited back in days. And yeah, the short answer is yes, and that was the long answer.
Thank you. The next one is from Weston Porter. He asks if the UI system is custom and if it's based on ITO or HTML.
Actually, that's a very good question because what I'm trying to do also creating a design system for the UI. And this is custom, but is based on Chatcn. There's this open source library. It's a React library, and this is a React Next.js web application. It is custom in a way that we customize it for our own, but you can always go and just pick them up and start working with it, and they are very customizable. And like they are doing a great job maintaining the library as well.
Okay, great. It looks really, really nice. I missed a previous question from Brian Markkanen. He asked if this process, he says this process is amazing, but there are tips for small shops with less technical know-how to accomplish anything like what has been shown.
Okay,
Yeah, sorry.
can I get the question again? Is it like
Yeah,
too complicated, I heard?
yeah, that your process, all your knowledge is quite complex, and how can
Mhm.
you simplify if there are small tips to accomplish something similar?
That's also what I
Mm.
was told. And also, this is something honest. Uh, all of the things I shared today, it they all beat me before. So I took a lot of time, wrap my head around it, using a lot of different resources. So I think it is very fair that some of them are complicated. But my idea was some of them are quite like the design pattern or software design pattern. They're all well known, and some of them are not secrets. So that's why I see that's where I showed that I would post blog posts for very specific things. And if you think that there is something that you are interested to know, uh, just reach out and then tell me, and then probably there wouldn't be any problem. So the data behind this and maybe the architecture of all these tools might be something that companies want to keep it for themselves. But the idea of how you can do very specific things, I think I'm very fond of kind of knowledge sharing. So please let me know, and I try my best to make this available for people.
That's great, thank you. And yeah, the next one is from Antonio Sausis. He asked what it takes convincing a firm to invest in building a tool like this.
It's not about convincing; it's just about we use all the opportunities that we have. to make things composable and reusable. So the tools that we use for different projects, if we create a very I don't want to use telling somebody that the Grasshopper is a spaghetti is very 2020 and before. So if you have this monstrous script and you wanted to use it again, um, that's the reason. If you want to convince anybody not to do that, if you want to use it again, you have to think before. So you have to put the foundation. So whenever we have this opportunity to create this foundation for our projects, during the design or working on different projects, we try to implement those scripts or those algorithms or what have you in a format that we can reuse later. And some of them are coming from different, like this is what I show you is part of, so it looks like it's a one piece, but it was done during different times. So connection between, I don't know, back end and front end using Docker. So we started using Docker a lot because we were working with Karlsruhe University on this project, and we wanted to containerize the OpenLB software, and we wanted to communicate it with Rhino, and that was a project. And that knowledge we used it in this other project that we have. So we didn't spend time in this project to learn or to do things with Docker.
Yeah. I think what I see now, it's a development of many years, and you have started a long time ago, and you're a lot of people working on it. So it looks really complex now, but I think it started with a simple project.
Yeah, it came with time. Yeah,
Yeah,
exactly.
because I was checking a question that asked what's the minimum number of developers required to build a system integration like this? Uh,
Minimum.
yeah, so I think
I
it started
I mean,
with
if you're
few.
ambitious, it's only you and your resources.
Yeah,
Um, but it depends. Like it's a time. If you want to do it faster or you wanted to do it at all, I think you can do whatever you want to do. Like I always encourage people to join the hackathons. There is this one hackathon that I always participate in Copenhagen, and if I get to, I do it like I did it in Barcelona once. And during the weekend in hackathon, um, so yeah, it is you or your team in a hackathon, and you need a weekend, and you see how much you can do.
yeah, perfect. Um, so the next one from Mayank is how is this workflow better than, let's say, using plugins like Butterfly, which again are based on OpenFOAM for CFD?
So all the workflows are great. I don't have anything against any workflows, and I think all the wrappers, because basically for all the software we use, if there's a core computation, we use a wrapper to make it easier for ourselves to use it. And there are other tools that are like great to work with depending on what you want to use for or Butterfly, or there are also some new tools coming. I met people, but at the end of the day, for us, it's very important to have full control of things, and full control in terms of OpenFOAM, for example. For me, is being able to detect whatever it is that you can detect in the process, from setting up the model to optimizing the computation. And if it's needed, you can change the code in OpenFOAM wherever you need it. If I didn't use Butterfly that much, um, but I don't know if it's possible. That would be another option that I might be interested to use. But like nowadays, I think it might be easier for you if you want to create a custom tool. You base it on something complex and something that works very well, like OpenFOAM, and then create your ecosystem around it.
Okay, perfect. So there are a few more, and we have 5 minutes, so it's okay. The next one is how do you manage the code base script library? And if you have any good recommendations to do this, so one can include more colleagues and improve collaboration.
I think this is very like personal. I mean, depends on the company's culture. If you have many people using GitHub, you can have this collaboration. If you don't have people using GitHub, or if there is nobody can maintain them, I believe I think for me, nothing should keep you away from collaborating. So one way or another, if it's just text that you can share through Teams or something, I think you should do it. But if it's possible for us, some of the projects we use GitHub a lot and it worked. But some others, because not all the people script and not all the people use Grasshopper and they might not have this common ground, there should be always a sharing system, and you have to find your own custom solution as well. So I don't have one answer for it, and that is also, yeah. I might be interested also to hear your opinions as well.
Thank you. Yes, and the last one is from Adif Salam. He says, amazing to hear that CN UI is used, and curious to know if the HL team, Henry Larsen team, have UI UX designers working alongside, or is it an iterate as we go approach from POC, MVP to production?
Um, I showed you open detail for that project, the research project. We had a UX UI designer, like a expert working on a project, because the project needed this division into, because it was mostly about the platform that we made. But usually we use our people's opinions and the users that we have in here to form this user interface and ask them how to make this better. And our goal is to minimize the UI as much as possible. But I found Shatsian something that is more progressive than the others. So like basically, it is like using that library as your teammate to do the hard things for you. But most of the times for MVP and POC is mentioned, I think, yeah, we iterate, yeah, iterate as we go. Yeah.
Okay, so thank you. That was the last one. I missed a few comments saying, a lot of comments saying, thank you for the presentation, that it has been amazing and really interesting. The timing was perfect. So thank you so much again, Ashkan, for presenting it,
Thank
for
you.
showing all that you do. It has been really interesting for us. And again, because I also have seen some questions in the chat that if the webinar has been recorded, it is, and I will try to upload it tomorrow to our YouTube channel, so you can always check all the presentation again when you want. Thank you so much. Have a nice afternoon. Goodbye.
Thank you, everybody. Thanks, Guillermo.
See you.
Talk soon.
Bye
Bye.
bye.